All right, this is Mr. Warwick. I'm gonna go ahead and go through a lot of the stuff here on the review. See if we can't get you in a good place to take the test. So starting off with reducing the radicals, a lot of these you should be able to kind of start doing the largest perfect square method. So like 75 is 25 times 3. We know the square root of 25 is 5. The square root of 3 remains the square root of 3. So this is square root of 3. If you come to something like 125 and you're not sure, you can do the birthday cake method. 125 is divisible by 5. That'd be 25. We can divide that by 5. That's 5. We divide that by 5. That's 1. Remember, when you're doing the birthday cake method, you don't stop until you end up with the one up there at the top, the candle on the top. And once you're done with it, you start looking for pairs, and then you have unmatched. So we have a pair of 5s, that's a 5 on the outside. We have an unmatched 5, that's a 5 underneath, okay? Always make sure birthday cake method, you're dividing by prime numbers, okay? Small prime numbers. If we do the same thing with 72, 72 divided by 2 is gonna give us 36. 36 divided by 2 is gonna give us 18. 18 divided by 2 gives us 9. 9 divided by 3 gives us 3. Divided by 3 gives us 1. We have a pair of 3s and a pair of 2s. Those both go on the outside. We have an unmatched 2 here. So that's going to end up being 6 square root of 2. The other ones, I'm just going to go kind of quick. 27 is 9 times 3. And we take the square root. So that's 3 square root of 3. 18 is 9 times 2. We take the square roots, that's 3 square root of 2. 144, the square root of 144 is 12, so it's just 12. I'm not gonna put this under any kind of radical sign because the answer is just 12. 216 is one that I don't remember. So if we start looking at 216, I divide by 2, that's 108. I divide that by 2, that's 54. I divide that by 2, that's 27. And that's going to be 3 and 9, which is going to be 3 and 3, which is going to be 3 and 1. So I have a pair of 3s, a pair of 2s, and an unmatched 2 and an unmatched 3. So a 2 and a 3 on the outside and a 2 and a 3 on the inside. I multiply where they're left over. So this is 6 square root of 6. Okay, 28, that's going to be 4 and 7. So this is 2 square root of 7. All right. Find the midpoint of the following sets of points. I'm just going to add the x's, add the y's, divide by 2. So 5 and negative 4 is 1. When I divide that by 2, that's going to be 1/2 or 0.5. 4 and negative 1 is going to be 3. I divide that by 2, and that's 1.5. On number 10, negative 1 and negative 6 is negative 7. Divided by 2 is negative 3.5. Negative 6 and 5 is negative 1. Divided by 2 is a negative 1/2. Man, couldn't have made these come out even, could we? 2 plus 1 is 3. Divided by 2 is 1.5 again. 4 minus 3 is 1. Divided by 2 is a positive 1/2. Negative 4 and negative 2, that's a negative 6. Divided by 2 is a negative 3. Finally, one that came out even. 4 and 2 is 6. Divided by 2 is 3. 5 minus 4 is 1. Divided by 2 is a 1/2. 2 minus 3 is a negative 1, so that's a negative 1/2. 5 minus 1 is 4. Divided by 2 is 2. And 1 minus 5 is negative 4. Divided by 2 is negative 2. Okay, again, it's just, we take the two x's, add them together and divide by 2. That's the first number. And then we take the two y's and we divide them by 2. And that's the second number. Okay, every single time, the exact same thing. Number 1 down here on the segment addition postulate, n is between these two. So I kind of don't have room for this one. AB is the whole thing, and that's 25. I know that the two parts together are going to make the whole thing, so 2x You can kind of see that. 2x minus 6 plus x plus 7 equals 25. Okay, I combine my like terms. They're on the same side of the equal sign. 2x plus x gives me 3x. 7 minus 6 is a positive 1, so 3x plus 1 equals 25. I subtract 1, so 3x is equal to 24. I divide by 3, and I get x is equal to 8. It says find the value of x. The value of x is 8. Then it says find an and nb. Be careful with this on the test. I believe there's a couple of these questions, just maybe 2, and they're multiple choice, but I don't think both of them are asking for x. I think they're asking for the length of one of the segments. So in this case, 8 times 2 is 16, and 16 minus 6 would be 10, and then 8 plus 7 would be 15. 10 and 15 make 25, so the whole thing works out. Just make sure you know exactly what's being asked for on the test. Over on the other side, we have midpoint. Because it's midpoint, I know that these are going to be equal. So 5x plus 9 equals 8x minus 36. I always start with the x's and I start with the smallest, so I'm going to subtract 5x from both sides. That's 9 is equal to 3x minus 36. I add 36. I get 3x is equal to 45. I divide by 3, and I get x is 15. Again, problem like this on the test, make sure you know what it's asking for. It doesn't ask for either one of these. In this case, 15 times 5 would be 75. 75 plus 9 would be 84. So I can assume that the other one would be 84. Okay? Solve the following problem. Using an algebraic proof. So given that 3x plus 2 is equal to 4x minus 8, prove that x is equal to 10. So I start with number 1, that's 3x plus 2 is equal to 4x minus 8. And over here on this side, that is my given. I would like to subtract the 3x from both sides. So my second part of this, if I subtract the 3x from both sides, I end up with 2 is equal to x minus 8. So I got there by subtracting. This is the subtraction property. Then the next thing I would do is add 8 to both sides. So I'd end up with 10 is equal to x. And I got there by adding to both sides. So that's the addition property. And then I would write this backwards. X is equal to 10. And that would be because of the symmetric property. Okay. There is one of these questions on the test, I know. It's a multiple choice question, and you're trying to fill in the blank over on this side. So make sure you go back, take a look at the notes on those. Make sure you understand the properties, when we're using them, what we're using them for. Find the distances for 9 and 11 on the previous page. So 9 is negative 4, 4, and 5, negative 1. The distance from negative 4 to 5 is 9. The distance from 4 to negative 1 is 5. So I go 9 squared plus 5 squared is equal to c squared. 9 squared is 81. 5 squared is 25. When I add those together, I get 106. That's equal to c squared. I'm going to take the square root of both of those. I'm going to birthday cake this one just real quick. 106 divided by 2 is going to give me 53. And I think 53 is prime. So yeah, this one just stays the square root of 106. Number 11 is 2, 4 to 1, negative 3. Hopefully that's kind of where we can see it. 1, negative 3. From 2 to 1 is 1. From 4 to negative 3 should be 7. So I'm going to square both of these, add them together, and get c squared. 1 squared is 1, 7 squared is 49, and that's c squared. So that's 50 is equal to c squared, and I'm going to take the square root. Now this one, if I have 50 and I divide it by 2, I get 25. I divide that by 5 and I get 5. I divide that by 5 and I get 1. That's a pair of 5s. So this one actually does reduce down to 5 square root of 2. The pair of 5s go on the outside. The unmatched 2 stays underneath. Find the missing endpoint. From -1 to -9, I would subtract 8. So if I subtract 8 again, I would get a -17. From 9 to -10, I'm subtracting 19. So if I subtract 19 again, I would get -29. Okay? From 2 to 5, I added 3. So if I add 3 again, I get 8. From 5 to 1, I subtracted 4. If I subtract 4 again, I get -3. From 5 to -10, I'm subtracting 15. If I subtract 15 again, I get a -25. And from 2 to -2, I'm subtracting 4. If I subtract 4 again, I get a -6. From 9 to 4, I'm subtracting 5. So if I subtract 5 again, I get -1. From -10 all the way up to 8, I'm adding 18. So if I add 18 again, I get 26. Okay, whatever we did to get from the endpoint to the midpoint, we're just going to do that one more time. Okay, and now we come to the compass section of what we're doing. Hopefully you remember how to do this. I'm going to make a point down here for both of these segments. I set the center of my compass on my point A here. I move until I can see through the opening of my compass that dot there at point B. I make that arc. That lets me know, especially on the test where you're going to do this, that you did measure that with the compass. I move my center down here to the other point. I make my mark. And then I'm going to use the straight edge to draw that in. There we go, a copy of segment 1, segment AB there. Same kind of thing here, set my center on A, move my measurement to B, make my mark so you know I measured it. Come down here to A, make my mark again, and then I'm gonna draw this in. Okay, there's my copy of AB. For numbers 5 and 6, measure the angles and copy the angles. It's two different things. You're going to be expected to do both of them on the test. I'm going to go ahead and fill in this dot here on the vertex at A a little bit on both of these so that I can see them a little bit better to measure. I get my center there. I line up on the bottom of that angle so that it's at 0. And this should be, looks like a 40-degree angle. This one over here, I get my center there on the vertex, line up the bottom of that one. This one appears to be a 135-degree angle. Okay, make sure you know how you're measuring it, make sure you know what you're looking at. So then we're going to copy these. So I'm going to come down here and I'm going to give myself a nice line to start at with my vertex. I'm going to give myself a nice line over here to start at with my vertex. So I put my center on my vertex. I come out just kind of here in the middle. Doesn't really matter that much where. Just got to have enough room. I make an arc that goes through both of my rays. And then I come down here and I'm going to copy that arc. Okay, then I'm actually going to adjust this. I get on one intersection of that arc. I move to where I can see that little X marks the spot through my opening there. I make that mark as well. Then I come down here to this intersection. I create that intersection And then I'm going to use my straight edge, going through those to copy that angle. Okay, one more time. I set on my vertex first. I make, in this case, a huge arc that's going to go through both rays. And then I'm going to need to come down here and copy that huge arc. Okay, then I'm going to get on one intersection of that arc, move to where I can see the other one, make a mark that shows I measured that. I guess I'll have to flip this around for this one. Get on my one intersection, make my mark. There is my mark. Use my straight edge to copy that line, and I should have another 135-degree angle. Okay, if you get stuck on this, remember, this is on a video. You can always go back, pause it, go back through it, kind of slow it down, pause it where you need to, make sure you know how to do this, and good luck on the test.